All right, welcome to part 3. Got cut off by the old 10-minute YouTube thing. So let's finish this up. We have our feasible region, and now the most important parts of the feasible region you will learn are the vertices, where all of the lines intersect. So this is where we'll get to use our fun little star font here. And we want to utilize all the vertices of the feasible region. So there's one, there's one, there's one, and there's 5 of them. Okay, and what it says is, and there's this vertex principle of linear programming that basically says, okay, where this is going to maximize is at one of the vertices. So we want to go ahead and find all the values of these vertices and then plug them into our objective function to maximize our profits. So let's go ahead and find all these vertices. And this won't be too bad because these intersect in a nice spot. So right up here, this vertice is 0, 10. So of course you could plant 10 acres of rye and no wheat. Or you could plant 10 acres of wheat and no rye. Maybe that'll give you the most money. You could plant 5 acres of wheat and no rye right here, but tell you what, right now that's not going to give you the most money, but it is one of the vertices. And then here you could also plant no acres of wheat and 5 of rye. So there's the 4 easy ones, and then the more difficult one is this right here. And to be exactly certain we know what that is, we could use our graphing calculator. Well, actually, we can use our graphing calculator to do all of this, which we will, but we're starting out just doing it by hand. But the long way to do that would be to set up a system of equations with the blue and the red inequality, but you make them equations to find out where they intersect, because remember, that's where they intersect. So let's take the blue and the red and let's make a system of equations just to double check we know that vertice. So here I've copied these on a new page, and I'm going to, if I want to find the line, I'm not worried about when they're less than or equal to. I want to know where they're equal to, so I'm going to change these to equals because I want to know where that line intersects. So this is just a 2x2 system of equations, and I'm going to actually use elimination. I'm going to slide some of these around a little bit so they line up. So you remember, you want the R's and to line up, and you want the W's. I guess I'll have to separate that. But you want everything to line up nice and neat here. So I'm going to use elimination. So I'll multiply the bottom equation by -100, and that will eliminate R. So multiply by -100 on the bottom. That's going to eliminate R. And so we'll solve this. And this will be then -1,000. Okay, I will have then 50 W. R's are going to eliminate equal to 200. So that means W is 4. And that's what I thought it was, but I wanted to be sure because it looked on the graph like it was 4, but I just wanted to be sure. So remember, now you take that, and I always use orange in class for this, and then you back substitute into one of these equations. Of course, the easiest one is this one. So 4 plus what number equals 10? And so then you'll know that, okay, my rye, the acres of rye, has to be 6. All right, so now that confirmed that this point right here was the point 46. All right, now what we're going to do is we're going to take those 5 vertices and we're going to plug them into our profit equation, which was way back from the previous page here, and we're going to see which one makes the most profit. So, and a couple of them, I'm just going to rule out by using common sense. 5, 0, and 0, 5, these ones are not going to produce the most profit. Okay, 10, 0, and 0, 10, and then 4, 6. I have to check those. All right, well, which one, if I go back, the ones I'm checking, here's the points I'm going to check. 10, 0, 0, 10, and 4, 6. Now, whichever one's cheaper, which is the rye, you get less money for rye, that means that 0, 10 is not going to maximize. So I'm going to not even check that one because I get less money for rye than I do wheat. So of course I'm going to get less money for 10 acres of rye than I am 10 of wheat. So if I put 10 in for W, that's going to be 10 times 500, which is a $5,000 profit. So for this amount right here, putting 10 in for W in the profit equation, that's going to give me $5,000. Okay. Now, if I put in 4 acres of wheat and 6 acres of rye, that's going to give me a profit of 4 times 500 is 2,000, and 6 times 300 is going to be 1,800. All right, so what this tells me is that it makes most sense for the farmer because 2,000 and 1,800 only gives me a $3,800 profit as long as I did all my calculations correctly. So that tells me that he should just plant all wheat. And you know, when you think about this problem, if you didn't overanalyze it like we did, yeah, it would make sense to plant all wheat because it gives you way more money back. However, you're just not sure because it costs a little more as well. So wheat does have a cost of $50 more than rye. So, you know, you might have been able to guess the solution to this right off the bat, but this just confirms that, of course, that is the best plan for him to plant all wheat. So the vertice that wins the maximization is this one right up here. This is the winner at 0, 10. Or did I get that wrong? Just kidding. It is not 0, 10 because rye is cheaper, so let me undo that. It is 10, 0. So this vertice, he should plant 10 acres of wheat because he gets $500 for every acre of wheat. So this vertice here gave him a profit of $5,000. All right. Well, there's one example of a linear programming problem, and it does take a bit of time. So if you watched, thanks for watching, and I hope it helped, and we'll see you in class.